Hello, students. Welcome to our today's lesson. Today, we are going to study about the input devices in a PLC. And we have different input devices into a PLC. And we are going to start with the first category, which are the sensors. And the term a sensor is used for input for as an input device that provides a usable output in response to a specified physical input. And for example, a thermocouple is a sensor which converts a temperature difference into an electrical output. So an example of a sensor that we have is the thermocouple, which is able to convert now a temperature difference into an electrical output. And the term transducer is generally used, that is another kind of a sensor. So we have a transducer, which is generally used for a device that converts a signal from one form to a different physical form. Now I want us to get to see the different types of sensors that we have. And before we go to that, let's get to see these terminologies that are used in sensors so that you may be able to understand them. And the first terminology is accuracy. And accuracy, it is the extent to which the value indicated by a measurement system or element might be wrong. For example, a temperature sensor might have an accuracy of 1 positive or a negative 0.1 degrees Celsius. So that is what we call the accuracy. In short, it is the deviation from, or it is the extent to which the value indicated by a measurement system or element might be wrong. That is the definition of an accuracy. The other one is the error, and the error of a measurand, the measurand is the quantity that is being measured, or whatever is being measured, or its quantity. That is what we call a measurand. And the error of a measurand is the difference between the result of the measurement and the true value of the quantity being measured. So that is what we call the error. I know you have studied error in EMFD, but we are just repeating the terminologies, which is also good. The other one is number 3, range. And the range of variable of system is the limit between which the input can vary. So that is what we refer to as a range. And for example, a resistance temperature sensor might be quoted having a range of negative 200 to positive 800 degrees Celsius. So that is the range in between negative 200 to positive 800. So it's just a range. Whatever is in between 200 and 800, that is the range. So that is an example. And when the input value to a sensor changes, it might take some time to reach and settle down to the steady state value. The response time, this gives us the response time. Let's get to see what response time is. And the response time is the time which elapses after the input to a system or element is abruptly increased from 0 to a constant value up to the point at which the system or element gives an output corresponding to some specified percentage, e.g. 95% of the value of the input. So that is what we call the response time. The other one is the rise time, whereby the rise time is the time taken for the output to rise to some specified percentage of the steady state output. So that time that is taken by an output to rise to some specified percentage of the steady state output is what we refer to as the rise time. Let's get to see settling time, and the settling time is the time taken for the output to settle within some percentage, e.g. 2% of the steady state value. So you see, once a wave propagates, it reaches a time when it will start to settle down. So that settling down until we start, it's like it will start having a steady state flow, is what we refer to as the settling time. So thank you so much. So those are the different terminology that we have in sensors. We are going to see the different types of sensors that we have in our next lesson. Thank you so much.